right, with multiplicity, like I said, I think it might be easier if I kind of to remember from last week. Okay, with an example of an equation. Multiplicity root corresponds to the power of each term in the factored form. The terms give us the zeros. The power gives you the multiplicity. So if you take a look at this equation, well, x plus 3 is automatically to what power since it's not written? It's to the power of 1. Okay? X plus 1 squared is to, we would say it has a multiplicity of 2. And then x minus 2 cubed is a 0 of multiplicity 3. Well, what does it mean to have a multiplicity of 1? I'll come back to this. Multiplicity of 1 means it just goes through the point. Okay, it has to cross through the point. Multiplicity of 2 or 4 or 6 means it bounces at that point. It doesn't go through it. It bounces. And then a multiplicity of 3 has that bend or squiggle in it. Okay, so we have those cases, and those are kind of the main ones. And I think we did one, yes, number 2 up above should have a multiplicity of 3, and so it goes through there and with a bend, okay, on that. All right, make sure you understand what multiplicity refers to. It's that power, okay, and then how it shows up in the graph. All right, now let's flip it over, and we're going to take a look at just some different equations, what their graphs look like, okay, from here. All right, so here's your first one, and I'm going to go through a couple other things that are important. First is the leading term. Now, if you have, well, let me think here. Let me just make something up. F of x equals negative 8x cubed plus 7x squared plus 5. What is the leading term of that? It would be negative 8x cubed. Okay, so what does that tell us? It tells us the end behavior. It's cubic, and it's third degree and it has a negative. Well, for a cubic, an odd degree, it opens in opposite directions, but which one is a negative? It would actually be the second one where it goes from high to low, right? All right, I don't have it written in this form, but you can still tell what the leading term is. It's not that difficult. If you would FOIL all of this out, really you just need to take whatever's with the x's, multiply those together, get your leading term. So my leading term will be this x times this x. But now what do I have to treat that? Since the whole thing's being squared, that's really a what? X squared. So it's x times x squared, which is a final value of x to the 4th. So the leading term is x to the 4th. What is the end behavior of a function as x to the 4th? If you need to look back. Does it open the same direction? Does it open in opposite directions? Okay. Hopefully you remember that it opens in the same direction, right? And does it open up or open down? Opens up. So here's your end behavior. It's like a parabola. You know, there's a lot going on in between, but at the far left and the far right, they're both going up towards infinity. All right, now for end behavior, to write it out as x goes to infinity, f of x goes to infinity as x goes to negative infinity, f of x goes to negative infinity. All right, so we took care of end behavior, which is we take from the leading term. Now, how about the zeros? So zeros, we have x equals, since it's a negative 3, we have x equals 3, which is a multiplicity of, what would that be? Multiplicity of 1, right? Then I got x equals negative 2, which is a multiplicity of 1. And then x equals 5, Multiplicity of 2. Well, what does the graph do with the one with the multiplicity of 1? It goes straight through, right? What does it do with the one with the multiplicity of 2? Bounces. Okay. Now, I'm not concerned like with what your y values are. I'm just concerned with the general shape. So put a dot at 3. 1, 2, 3. Put a dot at -2. And I'm going to put a dot at 5. Now, one thing you got to watch is these aren't always going to be in order. So you don't just make sure that you identify the one with multiplicity of 2 is the 5. It bounces there. All right, so what happens here? So it has to have this shape. So it has to start, and it goes through, this is -2. It goes right through it. Okay, it's going to come back up, goes through this one, and then what happens here? Bounces. So it has to follow those rules where it goes through, and bounces, and then it gets self-satisfied, the end behavior goes up. So that's what I want to see. Now make sure you don't have any, and especially when these are a little bit tight together, like make sure it's clearly rounded off. It's not like a check mark or anything. It cannot be a V shape. It has to be a rounded shape, smooth curve. If you need to, space out your X coordinates, change your scale if you need to. Okay. All right, so that's that first one. All right, second one here. F of X equals -2X times X minus 4 times X plus 2. All right, now you should have a little bit of space under the graph to do the leading coefficient stuff. Leading coefficient, what's that going to be here? Okay, so take a look, take a second, look it over. Leading term, I should say, leading term. All right, take everything with an X, including the -2 with it. So you're going to take -2X times X times X, which is -2X to the third. So think about the end behavior. -2X to the cube. You don't have it memorized yet. How does it opens in opposite directions? But is it low to high or high to low? So, okay, here are your two options for end behavior. And, all right, do you remember, Nathan, which one it is? The one on the left or one on the right?
I want to say the one on the left.
You want to say, why don't you say the one on the right?
Yeah, got it.
All right, good. The one on the right. Good. Because, let's see, when you plug in a positive number, if it's going to infinity, that means that has to be positive. So really it's going to flip it. So this would be the case right here. So as X goes to infinity, F of X goes to -infinity. And as X goes to -infinity, F of X goes to positive infinity. All right, how many zeros do we have? Lizzie, how many zeros we got? 3. This would be 0. So yep, 3 zeros, and they're all multiplicity what? 1. Okay, so my 3 zeros are X equals zeros. So I got X equals 0, X equals 4, X equals -2, all multiplicity of 1. All right, so -2, 0, 4. Make sure it matches the end behavior. They all go through them, nice and smooth. And it says it starts from the top. Make sure it clearly, like I said, it can be hard to draw when they're tight together, but make sure it clearly goes underneath the x-axis. Okay, for that one. All right. Todd.
Is
this were like a test, would you ever take a point off for like not going too high on like the second bump?
You mean like right here?
Yeah.
No, I do not care, what it looks like as long as it goes through those points and above it. Okay, because we have absolutely no idea. Whoa. I don't want to do that. No idea where it hits. Okay, for that. And also, we're prepping to do this without your calculator. So don't think like, oh, I'm just going to take it in my calculator and then just copy it. Like all this, there will be a no graphing calculator part of this test. So just make sure you understand that. All right, take a look at this one. Do your end behavior, do your zeros. If you think you got it, graph it. We'll go through it here in a second, though. If you're not quite sure, that's fine.
So much silence in this video.
I know.
Are you like adding like music or something in the background? You could like edit this.
There's like cool transitions.
I was thinking of doing that tonight.
Or you could like some like person in like graphic design class or something. I don't know.
Maybe we could have a DJ in the back. Tyson, leading term. What do you think?
I have 5x to the 6.
Okay, so that would be x. That would be x cubed and x squared. So yes, x to the 6. So leading term 5x to the 6. So that means it's got to be like a parabola open up, okay, on both ends. And as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to infinity. All right, my zeros. You got 3 of them. First one, x equals 0. Multiplicity of what there? 1. Multiplicity of 1. Because it's to the first degree. Multiplicity of 1. We got 6. X equals 6. Multiplicity of, what is that one? Multiplicity of 3. And negative 5. Multiplicity of 2. So it hits at, what did we say here? Negative 5, 1, 2, 3, 4, 5. It hits at 0. And it hits at 6. All right, it has to have that end behavior. Okay, it has to have that end behavior. So what happens at negative 5 when it hits there? Since there's a multiplicity of 2, it's going to bounce. Okay, so that's the first thing that happens. So I start to the left of it, it's going to come down, it's going to bounce. What happens as it goes through, hits 0, it has to go through it. Now the squiggle the bend tends to be the hardest one, but you have to draw it so that it is recognizable. So you kind of head up towards this point. I go towards the left of it as you get close to it. Okay, flatten out and then go through that point. So there needs to be a clear, change of direction. Okay, flatten out and goes through it. If you're really bad and you're not sure if I'll be able to tell, make sure, go ahead and do this. Tell me it's a bend right there. Okay, if you haven't really if you're not sure if it's obvious. All right, so both ends open up. We got to bounce, we go through, we got to bend. Okay, for that one. All right, let's take a look at, yeah, we got two more that I want to make sure we get through here together. So negative x squared, x minus 3, x plus 4 squared. Leading term. All right, take this negative into account too. So it's negative x squared. Take that negative with it. And then we multiply it by an x and then an x squared. So it looks like I get negative x to the fifth. So the highest term, the highest degree has to be fifth degree. Now it's a negative. So think about its behavior as a function. So it's going to go from high to low. And that's on that very front page. Okay, that's on the way it talks about the end behavior of power functions. Now, that means as x goes to positive infinity, f of x goes to negative infinity. And as x goes to negative infinity, f of x goes to positive infinity. All right, my zeros. X equals 0. All right, x equals 0. What is its multiplicity? All right, as you're looking at that one. Okay, Dominic, what would the multiplicity of that 0 be? What do you think?
Let's see.
It's going to be that 2 because it's square. Yep, it's going to be multiplicity of 2. And then so x equals 3. That has a multiplicity of, what did we say, 1? And then the other one has a multiplicity of 2. X equals negative 4. So 2 of them will bounce, 1 of them will go straight through. All right, go ahead and graph those once you get everything done.
Zero.
Good. 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 Yep. 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 All right. All right, so negative 4, 1, 2, 3, 4, 0, and then what was the other one? 3. 1, 2, 3. Okay, at negative 4, it's going to bounce. When we said it has to start from high, so it bounces, and at 0 it bounces, and then at positive 3, multiplicity 1 is going to go straight through. Okay, so that's look something on those lines. I don't care which, peak is higher than the other peak, it makes no difference. How many turning points do I have? I got 1, 2, 3, 4 turning points, which means it has to be what degree? Fifth degree. Remember, there's n minus 1 turning points. Okay, at most. All right, now this last one, I'm going to give it to you because it doesn't look the same. All right, I can tell the leading term straight in front of me. It's 2x to the third. So I know that it's going to go from low to high. But what about the zeros? Can I look at it and tell the zeros? No, you cannot. It's not written in that nice form. So we got to convert it to that form. Well, it's going to get a little bit harder as we move further. But right now, this one isn't too bad because it has a GCF. What's your GCF for this one? It has an x. Factor out the x. So you do that now. So f of x equals x times 2x squared plus 5x minus 12. That factors again. Go ahead and see what you come up with when you factor it. Okay, what you did. But going forward, we gotta do that. This is where you can do grouping, so you can write that as 2x squared plus 3x minus 8x minus 12, and then group. And then group. And then do that. Oh, just thinking. Hard. You got it. Oh, no. Plus, it couldn't be the 2 and the 4, we could pull something out. All right, on to factoring, right? I mean, the better you can factor, just, I don't know, it makes life easy. Makes life a little bit easy. Katie, you got this, right?
No,
No?
pass,
Pass? What do they have to multiply together, give me?
pass.
12. Pass, she passed. Okay,
2x minus 3 and then x plus 4.
well, you're even gonna give me the whole answer?
Good job, Katie. Thank you.
Jen used her phone around.
All right, is it right?
Definitely maybe.
It's a definite maybe?
That's what I got, so.
Can I get
Never
a,
right, though.
can I get a yes? I mean, all you gotta do is check it. 2 times 4 is 8, negative 3, 8 plus negative 3 is 5, right? Now, those of you who did grouping, I could see what you were doing. You said you took 2 times negative 12, which is negative 24. Well, what multiplies to negative 24 and adds to 5? It was 8x, right, minus 3x. Don't forget, this is how you do the grouping. And then you take out the GCF there. And then that would be a negative 3. And then you're still going to get the same thing. Remember, the 8 and the 3 aren't your answers. They're used to get them. All right, so now I got it factored. I got it in a form that I can find the zeros. So my zeros are x equals 0, x equals 3 halves, and x equals negative 4. And what is what are the multiplicities for each one? 1. Multiplicity of 1. All right, on my scale, and I know yours is marked, but I'm going to space it out a little bit just to make it simpler. It might help you there. So if you want to cross out that 5, and I'm going to go every 2 blocks as 1, just so that I can space it out a little bit more. And then what do I got? I got negative 4 is one of my answers, or one of my roots. 0 is one of my roots, and 1.5. And we know it goes from low to high, and everyone has a multiplicity of 1. So we're going to go straight through each root, straight through. Okay, that's given the equation. We need to do one more thing here. If you need to put this on the back, that's fine. Play a little name that graph. I'm going to give you the graph. You're going to give me the equation. Now, both of these, the end behavior needs to be marked, so put the arrows on this. So if that is the equation, if that is the function, think what the equation would be. Okay. So here's your graph. This is negative 5. This is negative 2. This is 3. You can keep it in factored form. The only thing you need to double check, though, I want smallest degree, and then watch if it's positive or negative. If you think the leading term is negative, let me see something. Was that number 3? Just make sure there's a negative out in front, okay, for that one. All right, take a second to look that over. All right, Sierra, any ideas? All right, at -5, how's that going to show up in the function?
X plus 1.
Good. And will there be a power on it?
No.
Okay, good. And how about this -2?
X plus 2.
And will there be a power on it?
No.
Does it bounce?
Oh, wait. Yes.
So what power should be on it?
2.
2. Okay, we're going to do the least degree. So technically it could be a 2, a 4, a 6, or an 8. We're always going to do the smallest degree for this type of problem. So this would be 2. All right, and how about the third one?
X minus 3.
Okay, will there be a power on it?
Yes.
Of what?
2.
2. All right, should there be a negative out in front, or will the final, will this have a positive leading coefficient? Okay, Ian. Positive leading coefficient, so I don't need to put a negative out in front because it goes from low to high, and it's an odd degree. Is this final degree is what? 2, 4, 5th degree, which does that match up with what we have? Yes. Okay, take a look at the second one, see if you can come up with the equation for the second one. Jackson, what do you got?
I have like X on the outside,
Okay.
and then X plus 4, X plus 2,
All right, that's a -5, so I'm gonna make it X plus 4.
plus 5.
Or excuse me, X plus 5. X plus 5. Then what'd you have?
X plus 2,
Okay.
and then X minus 3 squared.
All right, good. Technically, it doesn't matter where that X goes. I mean, it looks better on the outside. I just wrote it in the order and I put the X in the middle. Doesn't matter. Okay. But both of these are going to be a positive leading coefficient. Hey, take a look at the number of turning points in the zeros. How many zeros does this one have? It has 3. How many turning points? 1, 2, 3, 4. How many zeros does this one have? 4. How many turning points? 4. So the zeros have to be the same to get the same number of turning points. No. So you had a different number of turning points. Okay. Page 347. Probably the last 3 are graphs. It would help. It's not not too important though.